Hey guys, Joe here. Welcome back. We've got a Doodads for you. Got a couple projects. Been real busy here in the shop lately, fixing power equipment, including this thing behind me here, hanging off the winch. This is a riding lawnmower that had some really pretty substantial transmission damage, and waiting for parts right now. I got a separate video on that, how I repair it. But in any case, I got a couple projects here I'd like to let you take a look at. Neither of which I can really take a whole lot of credit for inventing, but there's something that John Mills uses on his lathe quite a bit, and I'll make one of those, show you how I do it since you can't buy them around here. And second of all, I was watching Tom Lipton the other day, and he had a really cool little device that he had put on his Bridgeport, and I thought, yeah, that's something that's pretty easy to make, and you know, I feel like getting back on the machinery, so I'm going to try to make something like that too. So anyways, I hope you enjoy it, and thanks to all my subscribers and the new ones as well. I really appreciate the support, and we'll keep trying to make some good video content for you. So here's a couple of random clips that I have built in the shop here in recent history. Thanks for watching. Okay, so the other day I was watching Tom Lipton's channel, Ox Tools, and he was, I can't even recall what he was making, but he had this really neat little attachment for his mill table. And what it was a piece of aluminum. I think he had aluminum that he had, it was like an L-shaped piece where you could bolt it to the front of this, this little slot here, and it came down and it would stop the table, kind of like a carriage stop on a lathe. So obvious, so simple, but I never thought of it, and I said, you know, that's something that could come in pretty handy. So I kind of looked through my scrap bin and found a piece of aluminum here that would do the job. Just a piece I was doing some test cuts on and stuff. But anyways, what I'm going to do is I'm going to first put this in here and flatten it out. You know, get all the boogers off the top of it here, and then I'm going to cut a slot in here to make this an L, and drill a couple holes where it would bolt up to this thing right here and come down underneath right next to the gibs. And that way I could have an adjustable stop that I could slide back and forth in the slots and on either side, and basically when I'm hand cranking the table, it would stop it right at the exact place, kind of like a work stop almost. So anyways, I'm going to get this set up in the vise here. We'll get a cutter up here, and we'll get to making this little piece of stuff. Alright, get the shell mill in here. Crank this up to about 500 RPM. So no specific measurements on this. We'll just mill it off till we get a flat there. That was a 35 thousandths cut. There's another one. Okay, I'm just going to square up the other sides on this thing, and then we'll cut the little piece out of it. Okay, well, I ended up sawing this out of there because I'm cheap and I don't like turning all this aluminum into chips. Most of it I did on the bandsaw, but because of the tilt of the blade, I had to cut out the middle, which turned out to take a lot longer than I thought it would. If I knew what it was going to do, I probably would have just turned it all into chips. But now we just got to clean up the cuts here. So I got a 1-inch end mill in here. Not the sharpest thing in the world, but it'll do. So Okay, so that's about it, except for a couple of holes and some deburring. I'll pull you around to the front here, and I'll show you how I'm going to determine where to drill those holes. Okay, so we have to drill a couple of holes in this piece we just made, and what I want to do is measure the bottom of the slot. And over on this end it's 661, and over on the other end 654. So 661's the biggest. And then what I want to do is measure the slot. So 661, and then the slot is 357, 363. So we'll take the biggest of those. 363 divided by 2 is 181.5, plus that's 661. So we want to come off of this wall. Can you see that? No, you can't. We want to come off of this surface 842.5, say 843. And that will allow enough clearance so that this thing can ride along here and still, you know, bolt into the slot. So what I'm going to do now is put my edge finder in here. I'm going to come over. Find this edge. There. I'll set my Y to 0. And what I'm going to do first thing I'm going to do is deburr this edge. There, set my X. Okay, now we're going to take out the offset, so I'm going to move over 1/4 of an inch on the X. And move over 1/4 of an inch on the Y. Okay, reset X, reset Y. So now I know I'm on the corner there. So I'm going to move out that 842 and a half. Right there. Let's lock that. And now I'm going to measure this because it's just some arbitrary number. Holy crap. 4. So, I didn't plan that, but it's exactly 4 inches. So, let's see, 1 inch from either end, I guess. So we'll come over. How's that look? Yep, that looks pretty reasonable, actually. Alright, so we'll drill our hole there. It's 1/4 inch clearance. Okay, those will lock them both. Okay, move it over 2 more inches. Okay. Pop a center mark there. Yeah, we will. Nope. Some WD-40 here. Lock them up. Alright, we've got a little deburn to do, and this thing is done. Hang on, we'll get this out and I'll show you how it works. Okay, I had to cut down a couple bolts here, but now you can see how these are the little, I guess you'd call them T-nuts almost. They're not really T-nuts though. And they go right in the slot here. Okay, so slide this over, say you want to stop right there. Tighten this up. And now, when you want to stop at that particular spot, bango, exact place every time. So like if I reset my DRO there, 0, 0, 0, 2/10. So there you go. That's from the mind of Tom Lipton there, Ox Tools. Saw this on his video where he was cutting splines to put a wheel like this on his milling machine. Mine just has a keyway in it. But, yeah, I thought that was pretty clever. So, there you go, milling machine stop. Right on the money every time. Okay, thanks for watching. Okay, so here's the plan. I got a 82-degree countersink bit here, and that comes from this set, which I've had for years. I really don't use the big one a lot. Mostly I'm using these here, so I figured this would be a good candidate to make this out of. Now John's is kind of a unique thing where he has a 3-flute. It's kind of an unusual thing, but anyways, what I did is a bunch of years ago I bought, before Inco went out of business, I bought a bunch of these Morse Taper 1 to Morse Taper 2 sleeve adapters. And what I'm going to do, I was originally just going to turn a Morse 2 taper on a piece of bar stock and mount it in there, but I figure since I got this I might as well use it. So what I'm going to do is bore this out to accept this. Now you're probably wondering, how the heck am I going to hold this thing in the headstock into my lathe to bore it out? And fortunately I have a Morse Taper 5 to Morse Taper 2 adapter that I bought for turning between centers a long time ago. And so we're going to put that in there. It fits right in perfect. And then we're going to take the chuck off, and I'm going to mount this thing right in my headstock, right in the taper. And that's going to be the most accurate way of machining this. Okay, so hopefully you can see this indicator here. I've got the adapter mounted in my spindle. I've got the sleeve mounted in the adapter, and there's 0 run out. Okay, just for the sake of screwing around here, let's see. I got my tense indicator hooked up to my tool post, and I'm going to preload this thing to approximately 0. And let's see what the real run out is. Okay, so what I'm seeing here is about 2/10. Not too bad for an old crappy lathe, huh? With 2 adapters plugged into it. some of that might be bearing stuff too. But anyways, that's plenty accurate enough for what we want to do. So let's get to drilling here. Okay, so after taking a few measurements here, I decided I was going to turn this shaft down a little bit because the adapter, it starts at a 1/2 inch and it tapers down inside, and I don't want this wall thickness to be too thin. So I'm going to turn this down to 3/8, and then I should have plenty of depth here. Okay, so I'm not going to lie to you. There was a whole lot of stuff that didn't get recorded here. What I ended up doing was machining the inside of this sleeve for a press fit on the shank that I turned down. And I'm pretty sure that when I heated up the sleeve to press in the tool, it kind of got a little run out there. It's got about 0.02 of run out, which I guess isn't really too bad considering what it is. But if you look at the shank, it's not running out at all, hardly, maybe a 0.5 thousandth. And same thing with my sleeve adapter. So I'm not sure whether the outside barrel of this thing is a little out of round or what. But in any case, it's done, and here's what it looks like. Now this is press fit in here with a 0.02 press. So what I ended up doing was I heated up this sleeve adapter with my MAP gas torch, and then used my arbor press with a piece of wood on the bottom here to push this in. So it's in there and it's not coming out. But I think it came out pretty good, and we're going to see how it works here. Okay, I got just a piece of mild steel in here. We'll face it off. Okay. We'll center drill it. And I don't know, I'll just pick a drill out of here. How about an 11/32? Throw that in the chuck. We'll slow this down a little for that. Okay, that should be deep enough for a pretty good countersink. see what happens here. No, we're going to turn this way. Sweet. Looks like it's cutting all the way around too. See if it ejects. Yep. Alright. Another tool in the tailstock arsenal. And take a look at it. Not too shabby. Alright. That's it for this one. Thanks for watching.